In the last lesson, we learned about the angles of triangles. Now, a triangle is a very simple shape with 3 sides. But can we take this idea that there are some properties that we can calculate and then use to solve problems in triangles? Can we take those ideas and apply them to some more complex 2-dimensional shapes? You bet we can. What we're going to look at today are the angles of polygons. Now, poly means many and gon means side. So we're just looking at the angles of things with many sides. And all the way up to things with 12, 14, 20, 30 sides, we are able to use some of these basic calculations with. So for vocabulary, obviously polygon is just a closed figure with 3+ sides. So a triangle is a polygon. Now, we have to make a distinction between a regular polygon and an irregular polygon. So a regular polygon has all sides and angles the same. So a really good example of a regular polygon is a square. A square has all sides exactly the same length, and all the angles of the polygon are 90 degrees. So that's a regular polygon. So if we make a little chart over here with regular, and we'll put a square. Okay, so all sides and all angles equal. And irregular, a rectangle is irregular because 2 of the sides aren't the same, but we could have a 4-sided thing like that. That's irregular. When we're looking at something like a pentagon, we could have pentagon like that. All the sides are the same and all the angles are the same. So that's a really common notation to show the angles are the same, so use little circles. Or we can have an irregular pentagon, the classic house shape, which has maybe some sides the same, maybe some angles the same, but not all the sides and angles are the same. A convex polygon has no interior angles greater than 180 degrees. So all of these are convex polygons. A concave polygon has at least one angle greater than 180 degrees. So for example, you could have like this. You see how that one there is greater than 180 degrees? Greater than 180 degrees. That's what makes it a concave polygon. So that's some important vocabulary that we're going to use for the rest of this section of the unit. So now let's move on to actually using the vocabulary and using these ideas that we started with triangles last time. We're going to find the sum of interior angles of any polygon. So what kind of polygon is this one? It depends on the number of sides. We have 1, 2, 3, 4, 5 sides. Means that's a pentagon. Okay, and we're going to figure out what the sum of interior angles is. So I'm going to tell you that this angle is 108 degrees. It's a regular pentagon. All the angles are the same. So if, okay, regular pentagon, if that's 108 degrees, then this is 108 degrees. This one's 108 degrees. This one's 108 degrees. This one is 108 degrees. So what is the sum of interior angles? It's 108 need to write today. Try that again. The sum of interior angles is 108 degrees times, how many angles are there? 1, 2, 3, 4, 5. And that is 540 degrees. Now, is there an easier way to think of this? Yes. We can actually figure out a formula that could tell us always the number of angles. So, I'm going to redraw this pentagon. I know, it's fantastic, isn't it? And what we're going to do is we're going to start with something that we know. We know the sum of interior angles of a triangle is 180. So let's make some triangles. So I can make 1 triangle, 2 triangles, 3 triangles. I have 1, 2, 3 triangles. So the number of triangles is 3. Each triangle has 180 degrees, so 3 times 180 is 540. Oh, do you see a connection? So if we add up all the angles that we measured, so I know those angles in that first pentagon are 108 each because I picked it specifically for that. If we measure the angles and add them up, we get 540 degrees per pentagon. If we divide it into triangles and add them up, we get 540 degrees. Okay. Let's see if this will work for our octagon. So what we have here, this is 8 sides. That's an octagon. And one of the letters that we always use in this unit is the letter N. N represents the number of sides. I'm going to write that in red for you. N equals the number of sides. So here, N equals 5. Here, N equals 8. So let's start dividing it into triangles again. So I'm going to start in one point and I'm going to go, there's a triangle, there's a triangle, there's a triangle, there's a triangle, there's a triangle. Now I can't let my lines cross because then I'm not creating real triangles. I'm just creating a whole bunch of shapes that don't have any meaning. What I want to find is how many triangles fit into that shape without crossing or breaking the lines of other triangles. So I have 1, 2, 3, 4, 5, 6. So do you see any connection between the number of triangles and the number of sides? So you'll notice, okay, the number of triangles is always 2 less than the number of sides. The number of sides. Okay, so that is n minus 2. Now, in order to make a formula out of this, we're going to put it into our sum of interior angles equals. Now, do you remember this section over here? We said the number of triangles times 180 gives us the interior angle sum. And the number of triangles is 2 less than the number of sides. So if we have the number of triangles times 180 is the sum, but the number of triangles is 2 less than the sides, then we get this formula here, n minus 2 times 180 degrees. And that formula works for any number of sides, from 3 with the triangle, which is going to be 1 times 180, which is 180, and we know that's what the sum of interior angles for a triangle already is, all the way up to something with 25 sides, or 45 sides, or 65 sides. we can calculate the sum of interior angles no matter what, as long as we know what n is. So let's give it a try. And what we need to know here is what is the number of sides for this example. Okay, so I'm going to try and make some space here. Okay, and let's look at that first example. Go back to blue. Here, n equals 4. Look, there's 1, 2, 3, 4. N equals 4. Therefore, the sum of interior angles is 4 minus 2 times 180, which is 2 times 180, which is 360 degrees. Once you've done a lot of these examples, you'll memorize a bunch of them. You'll know 360 for four-sided shapes. You'll know 540 for pentagons. So you'll get really used to that. So now that I know 360 is my sum of interior angles, I can try and find this missing angle C. So I would say that 68 plus 126 plus 106 plus C equals 360 degrees. Let me add those up. 68 plus 126, 106 is 300, so 300 plus C equals 360, and angle C is going to be 60 degrees. And now I've solved that problem. That's what a lot of these problems are going to be like. We will get to more complex problems as we work through this. Oh, it looks like part of my page is missing. So we'll go a little bit quicker because we're running out of time. So this one has 1, 2, 3, 4, 5. We know that the sum of interior angles for a 5-sided polygon is 5 minus 2 times 180, which is 540. We got that from up top. Then we set everything equal to 540. 102 plus 159 plus 93 plus 135 plus angle B is 540. Add all those up. 102 plus 159 is 93 plus 135 is 489 plus angle B equals 540. I'm going to take this over here to finish. That means angle B equals 51 degrees. Excellent. You can see once we find the sum of interior angles, everything else is just basic algebra. When you're solving these problems on a test or an assessment, you must show me that step. It is important. The last little thing I want to know is, what about a regular polygon? A regular polygon like our regular pentagon, where all the sides are equal and all the angles are equal. Now, these are the only cases where I will tell you the number of sides and no other information. So if I said, let's look at this one. Okay, what shape is this? This is a hexagon. Okay. So if I said I have a regular hexagon, what is the measure of one interior angle is the question. Then all you have to do is find the sum of interior angles for any hexagon, and then remember that every angle is the same. So just divide by the number of angles, and you get the sum of interior angles divided by n, because the number of sides and the number of angles are the same. Okay. And in this case, that's going to be, one angle is 6 minus 2 times 180 all over 6. And that means your interior angle is 120 degrees. I'm not sure you guys can see that. There you go. The interior angle is 120 degrees. Thank you.